So let's expand out one of these products in two kind of important cases that turn up rather a lot. So a plus b all squared, of course, what's that equal to? It's equal to a plus b multiplied by a plus b. So this is a classic FOIL example, if this is how you want to go through it. Okay, so what's this? Well, it's first, so that's a times a, so that's a squared, we'll write it as. Outer, that's a and b, so this is plus a times b, plus the inner, so that would be b times a, plus the product of the last, which is plus b squared. Okay, can we simplify this a little bit? Well, of course, a times b is equal to b times a. That's the commutative property if you wanted multiplication. So this is a squared. They're the same, so we could write them as 2. A times b, I'll just write it as ab plus b squared. Very important standard example. It's the kind of one you want at your fingertips, really. A minus b squared is a very similar story. A minus b times a minus b. So the first, a squared, plus the product of the outer ones, so that's a times minus b, plus the product of the inner ones, that's minus b times a, and finally the product of the outer ones, or the last, sorry, so it's minus b all squared. So we're going to do this super duper carefully. What do I get? Well, this is equal to, that is done super carefully. Let's simplify this. A squared, a times minus b is just minus ab. This can all be rearranged to minus ab. This is minus 2ab. Finally, minus b all squared. Well, that's just b squared, so this is plus b squared. Remember, minus 1 times minus 1 is equal to 1. And minus b is equal to minus 1 times b. Okay. So, very nice. Two very important examples. How could I use these to show or find the true value of 103 squared? So let's just think about this. Why would I do this? Well, I know how to multiply kind of powers of 10, and 103 squared is equal to, so there are lots of ways to do this, but this is just kind of one quite nice one. 103 squared like this. So I'm doing this, as I said, because powers of 10 are easy to deal with in the decimal system. So if I expand this out, this is 100 all squared plus what? Well, it would be 2 times 100 times 3 plus 3 all squared. Right, so that's exactly this expansion here. So what does all this come out to be? This is going to be 10,000 plus 600. Is it plus 9 here? Is that correct? I think so. So putting all this together gives me 10,609 when all is said and done. So this is just kind of a good example of this. Overwhelmingly, in calculus, you're not going to be using this to calculate specific values for specific numbers, but it's an important piece of algebra that you need to be able to do.